All right, I'm Wayne. So what I'll be leading you through is, this is a more advanced session, so it's a little bit more advanced than we typically do for our mobile sessions at Connect. So in the beginning, I'm going to fast forward us through in about 8 minutes to what is Couchbase Mobile, why is it interesting, and then Jens and Adam will come up and go through the architectural aspects of how to build business-critical applications with Couchbase Mobile, both on the client side with Couchbase Lite and on the server side with Sync Gateway. All right, so just to start off, and I'll lead through this pretty quick from a what are businesses trying to do perspective, what are the outcomes they're trying to produce, and how does that map through to technology choices and the success of those outcomes, and then how can Couchbase help from a mobile perspective. So if we think about this from an outcomes perspective, we start with our objective in mind. All right, so businesses, why are they transforming? What are they doing day to day? They're trying to become more effective, right? So they want to deliver better services, better products at higher quality, at higher rates to their customers where they'd like to consume them. And to do that, they need to select a strategy and then apply the required components to meet that strategy. So if we look at the way that businesses can become more effective, specifically on their ability to deliver products to their customers, products and services, and they really are looking for a better customer experience. And that's a better customer experience from a buying perspective, from an evaluation perspective, and from an ownership perspective. That can be actual physical products, it can be digital products, it can be services, right? And so how do you drive a better customer experience in those areas, in those three areas of evaluation, buy, and ownership? Is really about delivering better products, so actually physically affecting the product itself and making it better, which means that they're going to be more satisfied with it, and creating more effective employees, which means that they're going to be able to support those three activities from a customer perspective, the buy, evaluate, and ownership perspective on the products that they're buying, right? And this applies whether you're talking about digital technologies or not, right? These problems can be solved with physical things like knowing who your customer is by writing that down on a piece of paper, right? That does allow the employee, if you're talking about like a hotel, for example, knowing who their customers are by writing that down is also a way to solve that. But of course, digital technologies can accelerate your ability to solve these problems using this strategy. And then from a requirements perspective, especially when you talk about business critical. So the reason we put business critical in this title is because it has a very specific meaning. It means it's business impacting, meaning that if the process stops, that business stops, right? Or some aspect of business stops, right? Or the satisfaction levels will go down because you have to shift over to something less desirable. So what are the requirements, if you'd like an ideal scenario through that, is that when you need it, they're always available. And then if you look, and that applies to both employees and customers. So if you're solving this with digital problems, and I'm going to put this in the hands of customers, employees, then that digital information needs to be available whenever I need it, right? Otherwise, I can't depend on it to drive a business critical process. And then they kind of change when you talk about, are you customer facing, are you employee facing, when you look at the always fast perspective. So when I pick it up and use it, is it going to work, right? But when I pick it up and use it and it work, is it going to be fast? So from a product's perspective, you're always wanting to help them buy or use the product more effectively, right? So they can be satisfied with the use of that product or service. And then from an employee perspective, it's really about allowing them to do their job at hand more effectively. So it's really just, are you talking about employee facing or are you talking about customer facing, right? But it's always in service of the customer and making that experience better so you can drive more sales and more satisfied customers, repeat buys, et cetera. So if you look at this from a technical perspective, assume we're solving this from a data perspective, since we're talking about databases today, then the fundamental concerns and the capabilities based on your technical choices fall into these key areas. And they're here. So the data location, what network requirement you have for reaching that data, the effects on the application from an availability and speed perspective, that is it available and is it fast perspective, and then what are the typical enabling technologies that are used in these cases. So on the first one, we can have a remote-only data store. That means it's stored in the cloud. To get to that data means you need a network connection. The effect of the applications is the applications will be sometimes fast and they'll also be sometimes slow, and the same thing for availability. And it's all dependent on the network itself. So if the internet's fast, then it's going to be fast. If the internet's slow, it's going to be slow. If it's not available, it's available. And if it's not available, and if it is available, then the data is available. What we typically see is some type of service interface on the back end, usually in the form of REST services or RESTful services. The next technical approach is put the data on the device, local only, right, with no connection to the server. But you do have always available and always fast, and this is usually implemented using a embedded database or data store technology. But it has the limitation of not being able to share data with the central data repository and not being able to bring data down. All right, so you have just a local store. And then there's a hybrid between the two, local and remote. It needs an intermittent network connection. So when the network connection is there, it'll use it. If it's not there, it'll just use the local store. And that also produces the always fast and always available case, but you are able to share it with the server. So you can send data to the server, or you can bring data down. And that's typically enabled using some embedded database and sync technology. Either way, you have to have an embedded store in some way to reconcile the differences between the remote store and the local store. And that's typically called sync. So what we're looking for to solve these, this business outcome perspective is we're looking in these two areas, local only and remote and local only. In most cases, you want to share with the cloud. So you're going to end up using some type of replication technology and local data store technology. Okay? So from a technical capabilities perspective, this is the one that fits most business critical use cases. Okay, so these are fundamentally data management concerns. What does that mean? All right, so we're managing data. Where do those concerns lie, and where do you need to check the boxes on the solution that you choose? They fall into three main areas. It's the functional, operational, and security concerns. On the functional sides, it's data storage, access, and transport. These are pretty broad categories. I won't go into all of the different details inside of them, but I'll just talk about access for a second. Access is key value, search, query, eventing, all of the ways that you access your data. The operational aspects are performance, scalability, and availability, and then integration. So integration with existing IT infrastructure and integration with future IT infrastructure as you need to bring it in. None of these systems typically exist in isolation, so that's a very important operational concern. And then the security concerns are secure data storage, secure data transport, data access control, and data revocation. Revocation is very important when you start talking about privacy, right? You give someone data, well, what happens when you want to take it back, right? And all these need to be ticked to really get to a good solution. All right, so all of these data management concerns exist in every layer and in the network and application stack. And Couchbase has specific solutions to resolve those operational, functional, operational, and security concerns in every layer of the application and network stack, and I'll talk about that here in a second. So if we look at the very bottom, we have Couchbase Server at the bottom, resolving the functional, operational, and security concerns of data management in the cloud, and then your applications are built on top of that, resolving those same concerns in every other layer in the stack. All right, they have to be resolved one way or another. Couchbase can resolve them at the storage tier, and then you do it above that. That's via our SDK, and then your services on top of that, your REST clients on top of that, and your application code on top of that. Then we have Sync Gateway, which resolves these functional, operational, and security concerns for accessing and synchronizing data over the web. And then you build your applications on top of that, solving those concerns across the intranet and on your application tier, whether that's mobile or web. And then our Couchbase Lite database resolves the functional, operational, and security concerns of data management on device, and you build your applications on top of that. So you can kind of mix and match these as you see fit, deciding what part of the data management concerns you want Couchbase to solve, and then you resolving the concerns for the rest of your stack. And so just a quick overview of Couchbase Mobile. Couchbase Mobile is Couchbase Lite, our embedded NoSQL database. It's a lightweight, fully functional, embedded NoSQL database. Includes key value, query, full text search, eventing, replication, and security. all on device. And this is both online and offline. So you have all of Nickel, all of full-text search right there on the device itself. Right? And it's always available and always fast. Right? In the middle tier, we have Sync Gateway, allowing you to synchronize and access data securely over the web. And Adam will get into the details of this, about how we manage security, how we do fine-grained security, how that differs across the stack, and what concerns based on your specific needs you need to resolve there. And then Couchbase Server, highly scalable, high-performance NoSQL database, as you're all aware of in the cloud. And then underpinning all of this is our full-stack security that goes from cloud to edge, resolving authentication, access control, encrypted transport, encrypted storage, and revocation that I talked about before. Okay? All right. So moving on to Couchbase Lite, Jens will come up and get into the details of that.
Thanks, Wayne. So I'm Jens. I will be talking about the Couchbase Lite side of things, what to do in your mobile app. This is more or less a grab bag of stuff. Hopefully it will be useful to you. I'll be talking about some data design, principles or best practices, some ways to do the UI controller design in the app, the pros and cons of bundling a preloaded database in your application, the option of using external storage for local data recovery, and then finally a bunch of important security topics. So it's your data design first. So the main choice here that I'm going to talk about is normalization or denormalization. So denormalized data is it's more JSON-y. It's where you can have child data represented inline in the document itself, often as like an array. So here we have a sample address card with a couple of street addresses in it that are just stored as nested objects. Normalized is more like what you'd use in a relational database design, where the parent and children are separate documents. So here the parent is the address card, and the children, the addresses are each individual documents, which they have a link in the owner field that's giving the document ID of the main address card. And so there you'd be using a query to look up all of the children whose owner is that address card. So normalization, the benefits are that you have smaller documents, and that means that they will use less memory when they're being loaded in and used by your application, which in the case of little documents like we're showing here, it's not such a big difference, but if you have quite a lot of documents, or if they do end up having larger data, that can make a difference to your app. There's a lower risk of getting conflicts when you replicate, because changes to an individual child document will not conflict with changes to another child document, whereas if everybody's trying to update addresses inside of the same address card document, then you'll run into conflicts there. You can have different security applied to different parts of the data. So like some of these child documents might have different security levels. This doesn't really fit in well with the example that I have here of addresses, but I'm sure you can come up with situations where some of the data involved in a larger construct has more security applied to it. So you could actually assign that to a different channel. There are also some technical limitations in Couchbase Lite for now that make this attractive, which is that the replicator always sends entire documents. It doesn't send deltas. So if you have a very large document and you change one small part of it, the entire document still gets transmitted over the network. So if you break out the pieces into their own documents, that's less data, less bandwidth being used. And the query engine currently in 2.0 does not support indexing arrays inside of a document. So if you had the denormalized approach where you had all of the street addresses stored inside of one document, you wouldn't be able to index those individual street addresses. So that has performance implications for doing queries on data that's drilling down into those. Both of those things are actually scheduled to be improved in an upcoming release of Couchbase Lite, though. So denormalization, one of the big benefits really is that a document is always kind of ACID compliant. Document updates are atomic. So it's kind of the only level within a decentralized system like this, document-oriented database like this, where you can be assured that you have complete consistency between data. If you store data across multiple documents, then especially when replication comes into play, there are likely to be intervals where you have sort of eventual consistency, where maybe one of the documents making it up has been updated by the replicator, but the other part hasn't. So if that's not acceptable, if your data requires that compatibility guarantee, your only choice really is to put it all into the same document. The security controls can be simpler just because you're only dealing with one document here, so you don't have to worry about having like multiple channels or things like that. And again, the coding can be simpler. You just like load in one document and just iterate over properties. You can update the document, just like create an array and put stuff in there. And it's more JSON-y. It's more kind of like the way that things get done with JSON typically, and often in web services and so on. So it's not really always one, always the other. And of course, this applies to the server side as well, but it's something you really need to consider when you're doing your initial data design. So another piece of data design is using blobs, or attachments, as they're also called. So the key thing here is that a blob does not actually live inside of the document. It's more of a reference. So here we have the document itself, and now we've got this photo property that has a blob object in it. And the key part here is that digest, which is a base 64 to SHA-1 digest of the blob contents. And we look that up in our blob store to find the actual blob data. And that's loaded on demand. So the main cases where you want to use blobs are when you either have large data or binary data, since you don't need to base 64 encode it. If it saves you some performance or memory usage not to load it with the rest of the document, like if you only sometimes need to display this, if you need to like grind through 1,000 of these items but you don't need the attachment, then it's definitely going to be more efficient to make that be a separate blob instead of being inline. If it changes less often, and again, this is due to the replicator design, that blobs do actually get replicated separately from documents. So if the document changes but the blobs in it don't, the blobs will not get replicated again. It's only when they change that they get replicated. So you can save yourself bandwidth again that way, where if this photo only changes once in a blue moon, but there's other stuff that's being updated a lot, then you won't have to be replicating that attachment so often. And finally, if you don't need to query it. So the query engine, at least for now, cannot load attachments or look inside them. So if you've got, say, like a bunch of XML data that you're storing in a blob because it's big, you can't actually go and get that data and query it or do full text search on it or something like that. That is something that might change in the future, but I would think it's probably not likely just because of what blobs tend to get used for. Okay, so let's talk about some of the UI programming. And functional reactive programming has become kind of a big buzzword in app design. If you're familiar with it or an expert on it, then please deal with my very superficial overview. I'm just going to be kind of talking about one important aspect of it. So we've got our model, view, and controller, or some kind of hybrid of those. It might be MVVM or whatever. And our model is going to be a class that internally is using a Couchbase light document or a query to bind its data. So the significant part of reactive programming that I want to call out here is the data flow, that you get user input from a view. That view sends a notification to the controller, to your controller code. And then in turn, your controller makes a change to the model. The temptation, like one way it's often done, is that your controller just then immediately turns around and updates the view to reflect that change. But the better design is to let the notification from the model, so you use a listener from the Couchbase Lite document or query. It notifies your controller of a change, and then your controller responds to that change by refreshing the view with the up-to-date data. What's really good about this is that there can be other changes to that model object, to that document. For instance, the replicator can be running in the background and suddenly pull a bunch of changes, including a change to that document that you're displaying in that view. Or there could be some other controller that comes up, and if you have a multi-window application, or if there's a pop-up that appears and somehow that makes a change to this document, everything is still going to be consistent in the UI because that notification is going to get processed the same way as user input did and update your views. So the views will just kind of always be responding to the current state of the database. There are a few caveats to point out here that the listeners, the document listener in 2.0 at least, it only tells you about saved changes. It's not every time you change a property in memory in that document object, but only when that gets actually committed into the database. So in your model class, you will likely want to implement notifications of your own at a property level. And some languages like Swift and Objective-C make this quite easy to do because it fits in with their notification or change listener mechanisms. So that way, that flow while you're editing the document will work even before you save, because you probably don't want to save the document every time the user clicks a checkbox. The listeners will tell you that the document or the query changed, but they don't tell you exactly what changed about it. They don't go and tell you an individual field has changed or an individual row in the query has changed. So you do need to go and be a little bit careful about how you update stuff. If it's at a small scale, you can just go and reload everything in the UI from the document. But at a larger scale, like if you've got a large table view or something like that perhaps, you may find that for performance purposes, you actually do need to check, well, did this thing change, did this thing change, and only update the ones that actually changed. Another important little thing is that, which trips up a lot of people actually, is that a query listener, the listener gets called when the query results change, not when any document involved in the query changes. So if you have a query that's returning like 2 different properties from the documents that it matches, and one of those documents gets edited but only a 3rd property changes, you're not going to get notified because the query results are still the same. So one way that this bites people is that if they're expecting that they'll get a notification and then they can refresh that row in their table view and load the document and display state from that document that includes state that's not part of the query. And in that case, your display is not always going to update correctly because, hello? Because the document changed in a way that the query doesn't know about. So the best practice is to make sure that all of the properties of a document that you're going to be using to render your UI are actually in the query results, in the result set. And then finally, query listeners, as currently implemented, are not cheap. So if you have a lot of them running at once, it can significantly slow down updating the database because the query listeners will keep on triggering and checking for changes every time there's any document changed. So you want to make sure that when your UI panel appears, you activate, you set up the listener, and when that panel closes or the user switches somewhere else, that you disconnect that listener. All right, preloaded databases are the next thing. So there's a use case where this can be good for you, which is that you're concerned about the first launch behavior of your app, where on first launch, there's like a big database full of stuff that has to be pulled from the server before the app is usable. And there's a lot of data that doesn't change that often and which is not sensitive, that is kind of like publicly available to anybody who can connect to that server. So what you can do is you can actually take a snapshot of your database at build time and embed that database, like the actual .cblite2 directory, into your application. So you'd actually do this as part of your build process. Maybe not on every build, but at least for releases, you'd do this. And then on the first launch of the application, if there's no database available, you call the database copy from path method to take that database that's inside your app bundle, which is, of course, read-only because your app is read-only, and it copies that into writable storage and also adjusts some stuff like assigning some new unique IDs. And then you open that and use that as your database. And then you start a pull replication, which will pick up any changes that have happened since that database was snapshotted. So the pros, obviously, this is going to shorten your initial pull replication by a lot. If 90% of the data is still the same as it was when you snapshotted your database, well, then there's only 10% of that actually has to get pulled in and updated. And even that 10% is there, it's just not up to date, so it might be showing older stuff. So ideally, that means that your app is usable just immediately when it first launches. And the user might be seeing some old data in there, but it's going to be kind of updating in real time as they're working. or you might have to wait a short while, blocking until some particular data gets updated. So, and of course, that can save you a lot of bandwidth from your server. The cons are that you do have to take this database, which can become large, and stick it into your app bundle, which increases the size of your app. So that increases the download time for the user. It may mean that like the Apple App Store has limits on how large an app can be and still be downloadable over a cellular connection. So people might not be able to download your app until they're connected to Wi-Fi. It complicates your build process. You've got to have a step that's going to create that database and put it into the app bundle. You have to make sure that you filter that database so that it only contains public documents, because if there are any sensitive documents in there, then everybody's going to have them when they start up, and you probably don't want that. And then you also need to periodically update that canned database, like maybe every time you release an update of your application, because it, of course, like yesterday's newspaper, it loses value over time as more and more of the documents in it become out of date. Local data recovery, this is sort of a niche case, but very critical for some customers. So the idea here is that if your users are entering data into the app while they're offline, and there's a danger that the device they're entering it on could get lost or destroyed before they can reconnect online, then this is a thing to consider. And this is an actual real-world use case that's applied to some of our customers who are doing things like package delivery, where I guess like sometimes their devices get run over by a truck or a heavy package gets dropped on them or something. So the idea is that you have a removable storage medium on your, like an SD card plugged into your phone. And you can create a backup database. You just create another database in the file system on that external medium and run a local-to-local replication, which is one of our Enterprise Edition features, from your main database to the external one. So which that does a backup, and it's an incremental backup just by virtue of the way that replication works. So you want to do a push only unless you're recovering for some reason. And probably continuous is the best bet, because then you can just kind of start that when the application launches and forget about it. And every change will very quickly, within a matter of a second or so, get backed up onto that external card. And so then as long as you can peel that SD card off of the asphalt and read it somewhere else, the data's not gone forever. Whew. I apologize for talking fast, but we have so much content crammed into here, and I'm trying not to run over my time. Data security, last but certainly not least. So the use case for data security is that your app has users. I mean, everyone needs to build in security into their apps. So for network security, you obviously need to use TLS, also known as SSL, and some platforms like iOS are pretty much requiring you to. It's very, very difficult nowadays to ship an iOS app that doesn't use TLS. One less obvious step is that your app should be authenticating the server. The authentication should be bidirectional, because in addition to the user credentials being sent to the server, you want to know, first of all, is that the real server? And the fact that you use TLS to connect to it does not 100% mean that it is the real server. There can be man-in-the-middle spoofs, especially using faked server certs. There are cases where root certificates have been leaked, so attackers have been able to create very plausible fake certificates that pass basic validation, but they're not correct. And they can run a server using one of those faked certs, and you will not be able to tell just doing regular SSL verification that you're talking to a fake server. This is a real-world thing that has happened. The way that you deal with this is you use what's called certificate pinning. You put a copy of the server certificate into the application itself. So the app now, just a priori, always knows what the correct server certificate is. And our replication configuration object has a property where you can give it the certificate that you expect. And if you set that property, the replicator will refuse the TLS connection if the certificate does not match the one that you gave it. This is really good for security. The downside is that if the server certificate ever changes, like it expires or got compromised or something, you now have to update the app before the app will be able to connect again. But it's still definitely worth doing. There's also authenticating to the server, of course. All I have to say about that is that it's definitely best to store the credentials, like the user password, in some kind of secure enclave provided by the OS, like the keychain in iOS. Making the user type in the password every time is actually really bad security, because that is an incentive for users to choose short, weak passwords, or to put the password on a sticky note stuck to the back of their phone or something like that. Local database encryption, we offer this in our Enterprise Edition product. Best practice here is to generate a random key, not a password, but just a random AES key of, now, do we support 120 or 256 bits? Do you remember what? Yeah, okay. That was iffy for a while. So 256 bits of like pure random high entropy data generated by a cryptographically secure random number generator that is not the rand function in the C library, but something that actually goes through the OS's entropy store. And then store that key in the secure enclave, again, the key chain or whatever. That way, you don't have to ask the user to enter it, and it's available in such a way that the user has to be authenticated to the device for it to be accessible, as a hacker wouldn't be able to get to it. Even better is if you can tell that secure enclave to require a biometric scan, like Touch ID or Face ID, to be able to access the key. That way, like every time you open your database, there will be a check that the user is actually present. How are we on time? How much time do we have left? Okay, good. So local database encryption for iOS, I want to say iOS already encrypts all user data. The file system that your application accesses and puts all its data in is encrypted. So if you do local database encryption, you're actually adding 2 layers of encryption, which may be overkill. So really the best way to get encryption with iOS is that you use one of these enterprise management tools to mandate that every user of the device has to have a strong passcode on their device, like not a 4-digit number, but an actual alphanumeric passcode. That provides pretty good encryption. There are cases where you may have to add your own. It's mandated by law for something like healthcare applications in some cases. If you're really worried about very, very sophisticated attackers who have the ability to break into a phone, such as possibly the FBI, although they don't always manage to be able to do it, possibly foreign intelligence services, but we really don't know. It's pretty outre. Or if your marketing department really says they need to have encryption as a checkbox feature. So it's more of an optional thing on iOS, in my opinion. Data leakage is another issue. If your application ever supports multiple user logins, or logging out as one user and logging back in as another, or re-entering the credentials that allows you to change the user ID, you need to make sure that each user gets a new, fresh database. If you just log out and then log back in using the same database, all of the documents that were there are still there, and that is likely to include ones that were, accessible to the old user but not to the current user. So they'll still be there. They may even show up in queries. So if you switch multiple users and they can be active, and you can go back and forth from one to another, then create a new database for each one and leave them there. You might want to name them after the user ID or something like that. If the app supports logging out and then starting over from scratch, logging in, make sure you delete the database and recreate it when that happens. And finally, some security concerns for the data recovery option that I talked about a few minutes ago. Pretty obviously, you should encrypt that backup database that's on the SD card, because you don't want to be that company that gets in the news because they left an SD card with 5 million social security numbers or passwords, in the backseat of a cab or something like that. But then for that encryption to make the database still usable when it's recovered, it has to be known somewhere off the device, because the scenario is that the device is toast. So one solution that I think will work is you store that key in the database, when the device first creates it, and then it will get synced up to the server, hopefully with access controls so that it's not generally readable. And then if the device is lost and the card is recovered, that somebody with the correct access permissions on the server can get to that document and read the key out of it. And with that, I'll turn it over to Adam to talk about Sync Gateway.
Perfect. Thanks, Jens. So yeah, again, might be a little bit of a whirlwind as we work our way through here, but again, I think all of us will be available afterwards if anyone has questions, if we want to do a deep dive. So yeah, calling back to the main categories that Wayne called out at the start, I'm going to drill into a few of these as specifically how they apply to Sync Gateway around functional requirements, security requirements, and operational. So functional, let's talk about a little bit about document management and lifecycle, specifically from the Sync Gateway's perspective. I think the first key requirement is you want the ability to work with your data at any point in the stack. So whether that's Couchbase Lite, as Jens has talked through, whether that's Sync Gateway, whether that's Couchbase Server. And when you're doing that, you want to maintain the security and replication guarantees that you're getting from the Couchbase mobile stack. To do that, we support that by enabling shared bucket access on Sync Gateway. When that's enabled, documents that get written directly to the bucket outside of the mobile ecosystem get imported by Sync Gateway and apply the necessary metadata that we need for security and replication. That additional metadata is stored external from the document in an extended attribute. What that means is the data integrity and what the document looks like if you're coming at it through Nickel, if you're coming at it through the KV engine. Looks the same as your original document, but we still have what we need in order to perform replication. Another important functional concern to think about when you're working with replicating data. Obviously, when you're replicating, a key concern is that you need to be able to replicate deletes. And so what that means is that deleted documents must be retained in order to be replicated to clients that aren't necessarily connected when the delete happens. Managing the lifetime of these tombstones that are used for replication is important. Over time, as deleted documents accumulate and those deletes no longer need to be replicated, you want the ability to recover the bucket storage that's being used for those, and you also want to avoid the replication overhead of, as new clients come in, you're sending all these obsolete tombstones that are no longer necessary. So to solve that with Sync Gateway, you want to set the metadata purge interval on Couchbase Server based on how frequently you expect clients to replicate. So the metadata purge interval, if you expect the majority of your clients to be replicating within a 30-day window, then you set the metadata purge interval to 30 days, and after 30 days, those tombstones are no longer retained, and you can reclaim your storage and minimize the replication overhead. So yeah, moving quickly, let's chat a bit about security. I'll try and give a short recap of Sync Gateway security model, Couchbase Mobile security model. At a high level, we have documents that can be assigned to one or more channels. So channels are, you can think of it as a kind of a tagging principle, really, where documents are being tagged as being associated with one or more channels. Users are then granted access to those channels, and roles as well can be granted access to those channels. And users belong to roles and can inherit channels through those. I think that one of the key questions here is there's multiple ways in which you can grant channels to users. And the different approaches have different use cases, and understanding which makes sense in a given case is important when you're architecting your application. So we have static grants, which are admin-based grants. So through an admin operation, you say this user should have access to channel ABC. This has minimal processing overhead, but relies on static naming. So your channel name of ABC is fixed and needs to be known at the time you're granting the channel. The other alternative is dynamic grants. So these are data-driven grants. So your documents, as they get processed by Sync Gateway sync function, are saying, okay, user A should have access to channel 1, 2, 3, 4. And what that channel value is can be flexible and adapt to what your data looks like. So it's basically data-driven dynamic grants. So at a high level, using static grants when you can makes more sense because they're a lot less computational overhead. Dynamic grants, though, are available when you need to solve a more complex use case. And just to kind of try and make that real a little bit, I think it's useful to kind of talk through a couple standard security patterns and what the channel model might look like and what some of the pros and cons are there. So let's start basic with a read-centric application. Here you have an application that's really just serving a large amount of shared read-only data. It could be something like a product catalog. Here you have well-known channel names. The documents are mostly public, and the channel names are primarily down as a way to group the documents. So documents get assigned to one or more of those well-known channel names. You have static channel grants to users. So at user creation time, you're specifying what documents they can read. The main benefits of this approach, it's highly leveraging the channel cache. So you have a lot of users sharing the same channels, pulling. I'll get in a little bit later about the benefits of the cache and why that's important. And this is suitable for kind of a high read scenario where you've got coarse-grained security access. I can talk a little bit more about once you get into a situation where you need users to be doing more modification of the data. One common use case that we see a lot of people using is managing user-owned data. So here, a given user might own a collection of documents. Typically, they're the only author for those documents, and in some cases, they're also the only reader of those documents. A user profile store is a common example. In this scenario, again, you can stick to static grants. You can assign each user their own channel using a static grant. Then each document's responsible for specifying the set of users that should have access to it. So within a document, you specify an array property, which would be a list of users that should be allowed to read this document. And then the sync function is channeling that document to those users. The key benefits here, the fact that we're using static grants reduces the computation time work that Sync Gateway is doing again. The other thing that's nice about this approach is it's a very intuitive model. It's easy to reason about who's getting access to which document. And because you don't have users moving in and out of channels, there's less, it's less complex to work out, okay, does this user have access to this document at this point in time? One of the drawbacks, it does require every document to be identifying the set of users that has access. You have a potential here for document bloat as you, with highly shared documents, your list of users that's being granted access to that can blow up. A common scenario is kind of a hybrid model between this and the previous approach. So you put highly shared read-only data into a commonly shared channel, and you move user-specific data to a channel per user model. A more complex approach to security to support really data-driven security would be kind of a channel per object approach. So this would be a use case where you have structured data with object-level security. So an example might be a sales app or a service application. You could have an object like a customer account, and a customer account would have multiple documents associated with it. Here, each document would be associated with that customer account's channel, and you would be dynamically granting users access to that channel, and when they get access to the channel, they get access to all the documents associated with that channel. This is more resource intensive on Sync Gateway, so as users move in and out of channels, we have to do more work to manage replication for those users. But the trade-off there is that you're getting a very fine-grained security access and routing model, and let you have kind of down to the document level control over what's getting replicated. So yeah, just to wrap up, let's go through a handful of kind of key operational concerns. One of the big ones for Sync Gateway is cache tuning. So Sync Gateway has two internal caches, which I'll talk about. Correctly tuning those caches can have a significant impact on system capacity and performance. So basically the amount of users you can serve from a given Sync Gateway node, the amount of the latency for against Sync Gateway, your caches have a big impact on that. So talk first about the revision cache. The revision cache is just a LRU cache of recent document revisions. Stores the revision body and is primarily around optimizing read and write operations. So on a request for a document, Sync Gateway isn't having to go and do a KV operation against Couchbase server to retrieve the doc. It's just serving it from its cache. Some high-level tuning guidelines that you generally want to size the revision cache such that the latest revision of the document is resident in the cache until connected clients have replicated. So if a Sync Gateway has a few thousand connected clients, you want to ensure that the revision stays resident until that document gets replicated to the connected clients. As kind of a rough rule of thumb, that usually means that your rev cache should be sized to at least 3 times your system writes per second. So that gives you kind of a 3-second window for Sync Gateway to push that out to everyone. Obviously, additional capacity there just provides some more tolerance for latency spikes. The memory usage associated with the rev cache, it's important to remember that it is storing the revision body. And so the memory usage associated with the cache is going to depend on your average document size. So I think that's the first cache to think about. The second one is the channel cache. So the channel cache is primarily is for generating sync gateway's changes feed, which is kind of at the core of replication. So it's maintaining an ordered set of mutations by channel. The channel cache is just document metadata, so we don't have revision bodies here. And here the tuning really depends on your use case. So if you've got intermittently connected read-heavy clients, where similar to the first read-heavy case we talked about, where clients connect relatively infrequently, but they're all reading the same data, that approach is highly optimized when the entire channel is resident in the cache. In that scenario, you have people coming trying to pull down the full channel relatively frequently, and you want to make sure everything's resident. On the other hand, if you have a deployment that's got frequently connecting clients, so people aren't typically disconnected for very long, here you can normally reduce the cache capacity to match your write throughput. So similar to the case for the revision cache, you just need to have the kind of recent history of a channel resident, and that's all that people are going to use. One important caveat for the channel cache, the cache, as we talked about earlier, we need, for a replicating system, you need the ability to replicate deletes. So the cache is going to include any non-compacted tombstones you have, as well as any channel removal markers. When you're considering the size of the cache, you can't just be thinking about how many active docs you have in the channel. You also have to think about tombstones and removals. Conflicts are another kind of key operational concern. Primarily, it's that you want to avoid or resolve your conflicts, and if you don't, over time, you'll end up with degrading system performance. So at heart, this is down to the fact that unresolved conflicts are going to increase the amount of metadata that Sync Gateway needs to retain in order to manage replication. That larger document metadata kind of hits you in three ways. I mean, it impacts your storage, it impacts your transport between Sync Gateway and Couchbase server. So Couchbase, whenever Sync Gateway is retrieving documents, it's pulling down that metadata. And then the additional CPU work by Sync Gateway to process that metadata. So kind of three main approaches to dealing with conflicts. One, resolve conflicts, which is something we've always had the ability to do. The second, Couchbase Lite 2.0 auto-resolves conflicts on the Couchbase Lite side. So if you're using Couchbase Lite 2.0, you're no longer creating conflicts in the system. You can get the same behavior through Sync Gateway's REST API by setting allow conflicts equals false for Sync Gateway. This key value operations with Sync Gateway then have CAS-like semantics. So basically, it will only let you update a document if you're trying to modify, if the specified ancestor is the active revision. So switching gears a little bit, the other key operational concern is availability. So ensuring that the system's available throughout node failure. As Wayne showed, we have kind of a multi-components to the stack. Any of those components can fail, and your system needs to be able to handle that. So Couchbase server node failure, Sync Gateway uses GSI with replicas to avoid any downtime due to view reindexing. So if a Couchbase node fails, Sync Gateway carries on. There's no interruption to your service. Similar for Sync Gateway node failure. So Sync Gateway is designed as a cluster of stateless nodes. Those provide redundancy. A client can transfer seamlessly to another Sync Gateway node and have no interruption in service. Typically, that's done by pointing your clients at a load balancer that's fronting your Sync Gateway cluster. We've made some enhancements in recent versions to ensure that there's zero downtime during upgrade. So query versioning and backwards compatibility within Sync Gateway avoids downtime and supports a rolling upgrade. And finally, we have a couple aspects that are still running as single node on Sync Gateway. So that's feed-based import and SG replicate. Currently, those are single node, and if that node goes down, there'll be an interruption until the node comes back up. In an upcoming release, we're supporting failover for those, so they'll be redirected to another node in the Sync Gateway cluster. A couple other topics around integration. I want to leave a bit of time for QA, so I'll kind of skip through those, but have a look at the slides when you can, and if anyone wants to chat about external system integrations afterwards, just come grab me.
This time is actually up. This session has ended. Thank you, Wayne, Jens, and Adam for covering a lot of ground in a very short time. They will be available for question and answer outside near the ConExpert bar. Otherwise, you can also get in touch with them via our public forums or through community.couchbase.com. Thank you.